Okay, today we're going to talk about solutions, which is basically what this whole unit's going to be about. And first you have to remember what a solution is. It's a homogeneous mixture, and we talked about it when we broke down matter. Remember, we had matter, and when we broke it down, we said it breaks down into two different categories. One was substances, I'm just going to abbreviate it, and one was mixtures. Solutions falls under the mixtures. The other one was heterogeneous mixtures. But if we look at what a homogeneous mixture is, it's where the composition is uniform throughout. So you're not going to see the individual little particles in a solution. If we look at, there's two parts to a solution. The first is the solute, which is the dissolved particles in a solution. For example, different salts, ionic compounds. We could have sugar. You can have lots of different solutes, but these are probably your most common ones that you're going to see. And then we have a solvent, the dissolving medium in a solution. So what we say is the solute, if you want to put it, is dissolved. Okay, that's is dissolved. And the solvent does the dissolving. Spell that right. Dissolving. So, the most common solvent is water. So if you think of it, the solute goes into the solvent. And then we have a solution. So let's look at a common one. Salt water. We have NaCl. So the solute in this case is the NaCl. It's dropped into the solvent, in this case water, and when it mixes with the water, the NaCl breaks up into individual ions. This is basically now a salt water solution. Depending upon how much salt we dissolve into a certain amount of water, we can get the concentration of this solution. So molarity, which we're going to learn about later, depends on the amount of solute dissolved into a given volume of solvent. Molarity, we use a capital M, and we'll talk about this later, but it is basically the concentration of a solution. And we've seen in the past something like 6.0 M HCl. We used that in a lab last unit. 6 molar HCl. And we'll learn about, well, what does this mean compared to 3.0 M HCl? And these are both concentrations of hydrochloric acid. So let's look at, how do we know that salt is going to dissolve into the water? So we'll look over here. We can ask the question, will a substance dissolve? Well, you have to look at what is the solute and what is the solvent. So I put depends on the nature of the solute and the nature of the solvent. So let's think about this. Everyone's gone to a restaurant. They've seen a little sugar packet and you drop it into iced tea. What happens to the sugar? Does it actually dissolve? I would say most of the time, yes. What about if you mix oil with vinegar? Think of salad dressing. Does it dissolve? Oil mixed in water. Everyone's seen the little droplets of oil that sits on the top of water. So we can say, does it dissolve? No. Or a Crystal Light packet, you know, the little packs, if you drop it in water, will it dissolve? So in each of these four cases, we can say, these two definitely do dissolve, and these two don't. We can look at which is the solute, which is the solvent, and which dissolve. To do that, we say, we have a phrase, like dissolves like. And this goes back to the covalent chapter when we talked about polar molecules and nonpolar molecules. So we say polar dissolves polar, nonpolar dissolves nonpolar. If they can dissolve, then they're going to make that solution. So let's go over here and look at different types of solutions. Solutions are all around you. We have solids, we have liquids, and we have gases. So I want you to think about it. Here's 4 examples of different solutions. This is how they exist, how we're used to seeing them. So for example, air. It's a gas, it's all around us. A soda, Coke, Sprite, whatever it happens to be. It's a liquid. Salt water, you've been in salt water, we've made salt water. It's a liquid. And then brass is a solid. So if we look at air, well, what makes up air? Different gases. So we can say that the solute is actually a gas that's been dissolved in another gas. And as it exists, it's a gas. Well, think of soda. What happens? Well, we have those little bubbles. Well, that's a gas. That's the CO2 that's dissolved into a liquid. When you pop the top, you release that gas and you see those little bubbles, which is called effervescence. So that gas was dissolved into the liquid to make a liquid. And when you pop the top, the gas is released. Salt water. We know it's a liquid. Well, what is it? The solute is going to be a solid. And it's dissolved into a liquid, which forms that liquid. Brass. 2 different metals dissolved. So we have a solid that's dissolved into another solid, and we have a solid at the end. So solutions are all around us. I don't want you to think of it just as liquids. Glass, like our window, is another example of a solution. So we have gases, liquids, and solids all being solutions. Next, we're going to talk about how do we measure the concentrations of these different solutions.